Alright, in this video I'm going to be talking about squares and square roots. So the first thing I want to bring up is this idea of a perfect square, because we just love it when everything is perfect. So a perfect square is a number that is the product of the same two factors. So remember, product means answer to a multiplication. And the two factors are the things multiplying each other, or multiplying by each other, okay? So if you look at this example, 25 is a perfect square because I can write it as the answer to a multiplication statement where the two things that I multiply together are the exact same number. Okay, so 5 times 5 is 25, and because we can write 25 as the same two numbers multiplying one another, 25 is what we call a perfect square. Okay. Now, in the last video, we talked about finding the prime factorization of numbers. So I'm just going to really quickly find the prime factorization of these two things. So 20, I could split into 2 times 10, and 10 can get split into 2 times 5. And remember, we put boxes around our prime numbers. Okay. And so 20, I can write as 2 times 2 times 5, okay? With 36, I could split that into 2 and 18, and then 2 and 9, and then 9 splits into 3 times 3. And again, I put boxes around all of my prime numbers once I've got them. So the way I write 36 is equal to 2 times 2 times 3 times 3. Now this prime factorization is actually kind of handy, because what this prime factorization allows us to do is it actually allows us to find perfect squares. So when I look at this prime factorization for 20, I have 2 2's and I have a 5. And the goal after I've done my prime factorization is, can I create two equal groups of the prime factors? So if I was to look at 20, I could split it into one group of 2 and another group of 2, and then I could put the 5 in this first group of 2, but my second group, there's not another 5. There's only the one 5. I would need 2 5's. Well, that's a problem. So I can't split this into two equal groups. I can have a group of 2 times 5, but then I have an extra 2 kicking around, or I'm missing another 5. Because I can't split my prime factors into two equal groups, we would say 20 is not a perfect square. Okay? I can't find the same number that's going to multiply by itself to give me 20. Now when I look at 36, on the other hand, I have 2 2's and I have 2 3's. And so because multiplication is commutative, I'm allowed to move the numbers around and the multiplication won't change, the answer won't change. I'm going to go 2 times, and what I'm going to do is I'm going to swap this 2 and 3. I'm just going to move them around so that it becomes 2 times 3 times 2 times 3. I just wrote it in a different way. And if you like, you could think about it in brackets, where I have one group of brackets, which is 2 times 3, and another group of brackets, which is 2 times 3. And if you think about those two groups, they are exactly the same. They both have a 2, they both have a 3. 2 times 3 is 6. And so another way I can write 36 is I can write it as 6 times 6. I can write 36 as the product of two factors that are the same. 36 then is a perfect square. So I can use prime factorization to tell whether something is a perfect square or not. And this actually is a very useful tool, and you'll continue to use this in grade 10 when you start looking for perfect cubes and perfect fourths and perfect fifths as well. Okay? So I'm going to add on to that definition of a perfect square. So we still say it's a number that is the product of the same two factors. But also a perfect square will have two identical groups of prime factors. So that prime factorization is actually one of our ways of telling whether a number will be a perfect square or not. So looking at these two values, 64 and 90, which of them is a perfect square? Well, I can find that by doing the prime factorization for both. So if I look at 64, I could break that into 2 times 32, and then 32 splits into, I'm going to write this one as 4 times 8, just because I can. 4 splits into 2 times 2, 8 splits into 2 times 4, and 4 again splits into 2 times 2. Man, I got a lot of 2's going on here. I got 1, 2, 3, 4, 5, 6 2's that all get put together there. And so if I think about having 6 2's as my prime factorization, those were all the numbers that got put into our prime boxes there. If I have 6 2's, it's very easy to see that I could break them into 2 equal groups, where there are 3 2's in each group. And 2 times 2 times 2 is 8. And so you probably knew 64 was a perfect square because you knew it was 8 times 8. And when I do that prime factorization, you can see that I get an even or equal number of each of my prime factors so that I can split them into 2 equal groups. Let's try it with 90. Let's see if 90 is a perfect square. So with 90, I could split it into, let's say, 3 times 30. And then 30 splits into 3 times 10. And then 10 splits into 2 times 5. So I'm going to put a box around all my prime factors. And I got 4 prime factors here. So that's a good start. 4 can be split into 2 groups. Let's see if it works. So I've got 2 times 3 times 3 times 5. So, well, with this one, even though I have 4 prime factors, I can't put them into 2 equal groups. Because if I try, let's say I went like this, 2 times 3, oh, but my other group then is 3 times 5, rats. What if I go 3 times 3 and 2 times 5? Oh, those are different numbers as well. I don't have 2 2's. I only have the 1 2. So only one group could get a 2. I have 2 3's, so that's good. Each group could have a 3. But they can't share that same 2. I would need 2 2's for it to work, and I would need 2 5's for it to work. So this one, 90, is not a perfect square because I cannot split its prime factors into 2 equal groups. 64 is a perfect square because I can split its prime factors into 2 equal groups. What we asked is to find the square of something. If I'm asked to find the square of something, it's really like asking, what is the area of the square with this as its side length? Okay, so it's kind of like saying, if I want to find the square of 4, it means think of a square where all 4 sides are the same, and the sides in this case are 4. What is the area of this square going to be? Now hopefully you remember from before in grade 7 and grade 6, we think of the area of the square as the side length times the side length, right? Or if it was a rectangle, we go length times width. In a square, it just so happens that all the dimensions are the same. So it's kind of like going side length times side length. And so we write that then as 4 times 4, and that gives us 16. 4 times 4 is 16. 16 is a perfect square because we wrote it as the 2 same factors multiplying together. Okay? But you probably have seen the formula also written like this, where it's s with that little exponent of 2. So that exponent of 2 in the top right corner, that's kind of our first exponent we're going to be working with. And what that exponent means is I'm going to take this bottom value, in this case s, or in our case 4, and I'm going to multiply it by itself. So you see there are 2 4's. That's because the exponent was a 2. So it means I'm going to take that base number of 4 and multiply it by itself. So we have this habit of calling it, if I'm trying to find the square of something, we tend to say 4 squared. And that just means take the 4 and multiply it by itself so that there are 2 4's. Okay? All right, if I was to look at this next one, find the square of 12. So same idea. It's like saying take a square. All the side lengths are 12. What is going to be the area of this square? So the area of a square is s squared. In this case, our side length is 12. So it's asking what is 12 squared. 12 squared means 12 times 12. That 12 is multiplied by itself. 12 times 12 is 144. So 12 squared is 144. So when you are finding the square of something, you multiply it by itself. Now this is different than find the square root of. So this word root changes what I'm looking for. When I'm asked for the square root, that is like being asked now, what is the side length of the square that has that area? So if I'm looking for the square root of 81, it means here's my square. The area of the whole square, all colored in together, is 81. The area of the square is 81. How big is the side length? And it turns out, because we've done this already, that prime factorization is actually the fastest way for us to solve this without a calculator. So I can split 81 into 3 times 27, and I can split 27 into 3 times 9, and I can split 9 into 3 times 3. And these guys here are all my prime numbers, and I can see that 81 has 3 times 3 times 3 times 3 is its prime factorization. Well, and it's pretty clear that since I have 4 3's, I can have 2 equal groups where there are 2 3's in each group. And so a way of writing 81 is 9 times 9. That helps because that means 81 is a perfect square. And so what we say, to find the square root, we use this check mark symbol almost. It looks kind of like a check mark. Similar to your long division symbol that you would have used back in elementary school. But now it is a check mark. And so we put this check mark of 81, and that is our way of saying, what is the square root of 81? So if the area is 81, what is the side length? Well, I know a single side in that square must be 9, because 81 can be written as 9 times 9, and I just take a single one of those 9's for the square root. So that means 81 can be written as 9 times 9. The square root of 81 is just that single 9. It's that one single side length. Okay? Let's do one more. Find the square root of 196. So again, what is the square root, that check mark symbol, of 196? I'm going to break this down using prime factorization. So I've got 2 times, and that's going to give me 98. 98 can split further. It's even, so I can write it as 2 times, and that's going to give me 49. And I know 49 is 7 times 7. So there we go. There's all my prime factors, 2 and a 2 and a 7 and a 7. This looks promising because I have 2 2's and 2 7's. Now again, multiplication is commutative, so I can rewrite it and move them around, and as long as I still have the same number of factors, the same number of each, the order I multiply them in doesn't matter. So I'm going to move them so they become 2 times 7 and 2 times 7. I've got 2 groups of 2 times 7. 2 times 7 is 14. So I can rewrite this as 14 times 14. So I know 196 is a perfect square. It's 14 times 14. That means then the square root of 196 is one of those 14's. Okay? So remember, when you are finding the square of something, it's finding the area of a square that has that as its side length. If you are looking for the square root of something, we are starting with that area, and we are trying to find how big the side length would be. Prime factorization plays a really large role in finding square roots, and will continue to play a large role in finding perfect squares, cubes, fourths, fifths as you move on into higher levels of math. So prime factorization is an awesome tool to be able to use.